Okay, we're looking at problem number 5 on the same 4.4 guided practice. And the difference between problem number 5 and your previous questions is you'll notice that there are two radicals in the equation, one on each side. The steps for solving an equation with radicals on both sides really don't differ any much from the previous ones, other than you will need to isolate one of the radicals, get it all by itself. In this case, both of them are already by themselves, and then raise it by the power of that. You're going to eliminate one radical at a time. It just so happens, though, when you have a radical on both sides of the equations without anything on the outside of them, they will both eliminate simultaneously. Let me show you what I mean. So we have two radicals here. Let's just pay attention to the first one. It's already isolated, so we're going to raise both sides of the equation by 2 to get, supposedly just to get rid of one of those radicals. Well, it cancels out, so we just get 2x minus 33 is equal to, and notice that this radical on the right hand side of the equation also cancels out, and you'll get x over 6. It's just whatever the radicand is. Anything that's underneath the radical, you just copy it down. Alright, look at the equation that we have here. Notice that we don't have any powers greater than 1. Therefore, this is a linear equation, just like in Algebra 1A when we're solving an equation. Alright, so this might look a little tricky. You're probably trying to think of, well, what am I supposed to do first on this? Well, I see an expression on one side equaling a fraction on the other. So I'm going to treat the first side like a fraction. I'm just going to put it over 1. Then what do you see there? Oh, a complex equaling a fraction, or this is proportional to each other. So I'm going to cross multiply. This might be a review. So I'm going to multiply the 6 times the whole expression, 2x minus 33, and the 1 times the x. So 6 times the whole expression, making sure that I write it inside parentheses, so that I know I need to multiply 6 times the whole thing there, is equal to, and then 1 times x is just x. I see parentheses, so the next step I need to do is distribute. So I'm going to distribute that 6 times 2x equals 12x, and 6 times negative 33 equals negative 198. Yes, I did use a calculator for that. Is equal to x. Alright, it's still a linear equation, so we're not trying to get this equation set equal to 0. That's what you do when you're solving a quadratic. So when you're trying to solve an equation, remember that you're trying to get your variable term on one side and your constants on the other. So I need to move that x that's over on this side to the other side with the 12x that's already there. So I'm going to subtract x from both sides. And I also need to move that constant of negative 198 to the other side of the equation. So I'm going to add 198 to both sides. Alright, so combine like terms, and I should have a variable term on my left. Negative, or yeah, that cancels out there. So 12x minus x equals 11x's is equal to the 198 on the right hand side, because the 198 on that side cancels out as well. Alright, so after I combine like terms, my final step is I need to isolate my variable. I have an 11 that's beside the x. If it's beside it, you have to divide it. So divide both sides by 11. And you'll get x is equal to, well, 198 divided by 11 is 18. Because our equation had a radical in it, you have to remember to check to see if it's a solution that really works. So we write down the original equation, but everywhere we see an x, we're going to replace it with 18. Alright, and simplify both sides of the equation. So we have 2 times 18 equals 36, minus 33 is equal to square root of 18 divided by 6 is 3. On the left hand side, 36 minus 33 is 3, so you write the radical square root of 3 is equal to the square root of 3. There's nothing else more to simplify, and the square root of 3 does equal the square root of 3. So that is a solution. So the final answer is x is equal to 18. Okay, ready to look at problem 6? In problem 6, notice we have a radical on both sides and both of our radicals are already isolated. I don't believe I'm going to give you any problems that the radicals are not isolated. I don't even believe on the ECA there are any of those like that where they're not already isolated. Even these problems that we're looking at, you may even just only have one on the whole test. So we've got them isolated. Let's square both sides of the equation so that we can eliminate the radicals. Okay, the radicals are eliminated. Now that they're eliminated, take a look at what type of problem you have. Is this linear or is it quadratic? It's linear. There's no exponents of 2 or higher, so therefore we are not trying to get this equation set equal to 0. We're trying to put our variables on one side and our constants on the other. So let's get all our variables on the left and our constants on the right. I have a 2n that's on the right hand side of the equation that I need to move. So I'm going to subtract 2n from both sides so that I have no variables on my right hand side of the equation. I have a negative 5 that's on the left hand side. That's a constant, so I need to move that to the right hand side by adding 5 to both sides. Okay. Ready to combine like terms? Negative n minus 2n is negative 3n is equal to 16 plus 5 is 21. I'll divide both sides by negative 3 to isolate that variable. So our n is equal to, well, positive 21 divided by a negative equals a negative. 21 divided by 3 is 7. The equation started off with radicals, so I must check to see if it actually works. Rewrite the original equation, but everywhere you see an n, replace negative 7. Now watch what I'm going to do here. This is a mistake that I see students make all the time. I have square root negative 5. The equation, the original equation says negative n. But because my n is also a negative number, I'm going to make sure to put it inside parentheses. I can't tell you how many people I see put negative because it's in the equation and then just write 7 because they think they already wrote the negative 7 down. Is equal to square root of 2 times n, which is negative 7, plus 16. Alright. Simplify each side of the equation. We're not going to take anything from one side to the other, just simplifying each side by themselves to see if they equal. So we have the square root of, let's read that out loud. What do we have underneath that radical? Negative 5 minus negative 7. Do we ever subtract integers? No, we change it to addition. So we're going to keep our negative 5, change it to addition, and change that negative 7 to a positive 7. So keep, change, change. Is equal to 2 times negative 7 equals negative 14 plus 16. Okay, let's keep simplifying. On the left hand side, we have negative 5 plus 7 equals the square root of positive 2. Is equal to the square root of negative 14 plus 16 is 2 again. Look, they're equal. You don't have to go any further than that. Once you can see that they're equal, the exact same thing, then we know it's a solution. So the answer to number 6 is n is equal to negative 7. Think you've got the hang of these yet? I'm going to do 2 more examples and then you can do the next 4 after that on your own and check your work. Alright, we have radicals that are already isolated, so let's square both sides of the equation. 12 minus k is equal to k over 3. This is like our first problem of this type that we worked with before. We have an expression equaling a fraction. So let's make that expression into a fraction so that we can see we need to cross multiply. 3 times the quantity, 12 minus k, is equal to 1 times k is just k. Distribute. 3 times 12 is 36 minus 3k sorry if you hear my daughter in the background, equals k. This is a linear equation, so we need to get our variables on one side, so we're going to subtract k, and our constants on the other, so we're going to subtract 36, so that we have just constants on the right and just variables on the left. Combine like terms, you have negative 4k is equal to negative 36. Yeah, I got all sorts of noise going on now. Divided by negative 4, divide by negative 4. So k is equal to a negative divided by a negative is a positive. 36 divided by 4 is 9. Okay, looking at number 7. Just like the previous problem we had before here, the radicals are already isolated, so we square both sides. 12 minus k is equal to k over 3. Once we've removed the radicals, we notice that we have a linear equation because nothing's squared. And I have an expression equaling a fraction again. So I'm going to change that expression into a fraction so that I can see, oh, I just need to cross multiply. 3 times the quantity 12 minus k is equal to, well, 1 times k is just k. Then I use my distributive property. 3 times 12 is 36 minus 3k is equal to k. This linear equation right now has a variable on two sides of the equation and the constant on the left. Because it's linear, I'm trying to get all my variables on one side and my constants on the other. So I'm going to subtract k from this side and put it on the left, and I'm going to subtract 36 from the left to put it on the right. Combine my like terms, that gets rid of my constant and my variable that's on the wrong side of the equations from each other. I'm ready to combine. Negative 3k minus k equals negative 4k is equal to negative 36. I divide both sides by negative 4. Get that k all by itself, so k should equal to a negative divided by a negative is a positive. 36 divided by 4 is 9. If you're trying to use your calculator to find out what negative 36 over negative 4 is, reducing it with your fraction button, you will get an error because the calculator doesn't know how to do negative denominators. Whenever you're trying to reduce fractions with signs, and first just ask yourself, well, if it's a negative over a negative, it's going to be a positive, and then just put your 36 divided by 4 in your calculator, or 36 over 4 using the fraction button. You should use the fraction button, though, to reduce those fractions. If you use your divide key, you might get some decimals sometimes. And fractions are always more accurate than decimals. Now that we have a solution, we have to check it. So plug in that 9 in the original equation. 12 minus 9, there we go. Have the equation. So 12 minus 9 is equal to 3, so we keep the square root of 3. Is equal to 9 divided by 3 is also 3. So we have square root of 3 equals square root of 3. They are the same thing, so we can stop right there. We know that this is a solution. K is equal to 9. 2 more. I'm sorry, 1 more. This is the last example, and then you can do your guided practices. Okay, we have the square root of 5a equals the square root of 3a plus 2. The radicals are already isolated, so let's square both sides to get rid of those radicals. 5a is equal to 3a plus 2. We have a linear equation, so we just need to get our variables on the left and our constants on the right. So we subtracted 3a. This is nice, there's only one term that we need to move. Combine your like terms. 5a minus 3a is 2a is equal to 2. That 2 is beside the a. We need to isolate it by dividing by 2. So a is equal to 1. Then we need to check to see if a is actually equal to 1. You have to plug it into the original equation. 5 times 1 equal to 3 times 1 plus 2. Keep the radicals there. Square root of 5 times 1, do not write 6. It is 5. Simple problem like that. I see that mistake happen all the time. Equals the square root of 3 times 1 is 3 plus 2. So square root of 5 is equal to square root of 5. Those are equal to one another, so we can stop right there. So our final solution is A is equal to 1. Go ahead and finish your guided practices and then use the self-check and correct. I will only give you the final answers though for those self-check and correct problems. If you do not understand how they got the answer, then please ask an instructor.